Hello guys, it's the Caribbean Bookworm, and today I have a fresh new video for you. Slightly more different than book reviews, but we'll roll with it and see what happens. So we've all experienced this before. You walk into a library or you walk into a secondhand bookstore and you get that fresh breeze of deliciously sweet aroma, or at least for some people it is very sweet, for others not so much, but I'm in that first majority there. I really love the smell of good old books. But what causes this particular aroma of old book? I went into a bit of digging and I realized that I had to actually brush up my chemistry for this. So without further ado, let's get into it. The smell of old books is often described as smoky, or as earthy, or even as vanilla-like. I don't smell any vanilla here, my friend. During an essay, a lot of people reported either having one of those odors or distinctly different odors actually. So why is this actually? The majority of books are made, of course, out of trees, and trees are made out of organic materials. They were living organisms. So what happens is actually within these trees, within these plant cells, you actually have this particular polymer, or actually chains of organic molecules known as cellulose. Cellulose is a very, very important organic molecule for the tree because it's actually what gives the tree its rigidity. It's actually what keeps it really, really rigid. Within papers of books, you have cellulose and you have lignin, and lignin reacts with the oxygen in the air, or it oxidizes, if you will, and this creates a particular type of acid, and this acid helps break down cellulose. And also the fact that cellulose breaks within this paper is what leads to the following beautiful, sweet smell of aromas. The fact that cellulose breaks down within these papers also makes it more breakable, you could say. As these organic molecules break down, you get a different aromatic carbohydrates. As if you remember chemistry class, carbohydrates are basically organic compounds made out of mainly carbon and hydrogen, and these aromatic carbohydrates actually also contain this particular group called a benzene ring. A benzene ring is actually an hexagonally shaped carbohydrate that contains 6 carbon atoms and 6 hydrogen atoms, and contains these double covalent bonds. The main thing about this particular group of carbohydrates, the benzene ring containing group of carbohydrates, or basically aromatic carbohydrates, is that they all have particular odors, particular scents, which of course, as you obviously guess, plays a role within the odors of which we gain from old books. As these cellulose and lignins break down, you get hundreds of these organic compounds, actually known as volatile organic compound. Yes, of course I had to Google that. Also known in short as VOCs. Much easier to remember. What these VOCs are basically organic compounds of which evaporates quickly into the air due to a really low boiling point. So actually some of them below room temperature, so it vaporizes really, really quickly, hence why they specified them under volatile compounds, or in this case volatile organic compounds, since we're dealing with organic molecules. The oxidation reaction of these lignins and then the breaking of cellulose, of course the slightest of little bit of movement within the structure actually causes or forces these VOCs to change it to gaseous form, because of course it vaporizes really quickly. You get things such as benzaldehyde, of which mainly has this sort of almond-like smell, and also you get vanillin, of which you can hear in the name itself, causes this type of like vanilla scent. All in all, scientists and chemists don't particularly pinpoint a specific molecule of which causes that sort of old book smell. It's actually just a combination of hundreds of organic compounds, of which reaches your nose, goes through your senses, goes through your nervous system, and of course your brain interprets that into a particular smell. If you found that interesting, please let me know in the comments below. I tried my best. If I missed some particular detail, hey, I'm not a chemist. Let me know, correct me, and stay tuned for more videos.